We will start with shear force diagram and bending moment diagram. As per the definitions we have written yesterday, you know that definition for shear force is algebraic sum of the vertical forces either to the right of the section or to the left of the section. So similarly for bending moment, you have the definition like bending moment at a section is algebraic sum of the moments either to the left or to the right of the section. So how will you draw the bending moment diagram and shear force diagram? So the thing is that you just take the simple example of a cantilever AB here. I have shown here. A is the fixed end and B is the free end. So in this cantilever you have got a concentrated load W acting at the free end. So the span is L. So you have the reaction components acting at the fixed support A. So there will be a vertical reaction here as well as a fixed moment also here. But you are not going to evaluate all these things. Without evaluating these reaction components, you can draw the SFD and BMD. So in this particular beam AB, for drawing the shear force diagram and bending moment diagram, you need to find out the values of SF and BM at each and every section. So let us first take shear force diagram. So for that I have taken a section here XX as well as another section X1 here. So this section XX is located at X distance from the free end. So this B is the free end. So this is X distance taken from the free end. So here why I have taken X from the free end is that it is better to consider towards the free end, because when you consider left hand side, this M and R has to be evaluated. So it is easy to consider always in cantilevers to the free end side. So that is why I have taken to the free end side, that is to the side of B. So I am taking it as right of section XX. So when you write shear force at X, I am written here right hand side. What is the algebraic sum of the forces to the right hand side of section XX? This is only this force W. So I have taken W. How I have taken the sign convention plus, that is with respect to this. How I have taken the sign convention is that this section XX I have drawn here. This is your section XX, and to the right of the section, if the arrow is downwards or the load is acting downwards, you take it as positive shear force. So automatically left hand side will be upwards. So this is the sign convention for positive shear force. Similarly, when you have here, if to the right of the section if the load is acting upwards, you have got negative shear force. So if it is upwards, automatically left hand side will be downwards. So always, otherwise you can remember it like that: right downwards positive and right upwards negative. If you study this one, this will automatically come. So you just remember only this one: right downwards positive means it is positive shear force, right? So all this is clockwise shear and this is anti-clockwise shear. So according to sign convention, here right it is coming downwards, so I have taken here plus W. That is a shear force value at X. Now I have taken another section X1. So this is the section X1 over here. So this is section X1. So it is at a distance X1 from the free end. I have marked here now to define the section. So shear force at X1 means, again, when you look to the right hand side of X1, only this W is there. So this W, you can again write shear force at X1 is also W. So you can write here as plus W. So again the value is constant, even if it is at X or X1 or X2, whatever it is same as constant value capital W. And again the sign convention is downwards, that means right downwards is positive. So you have got plus W. Similarly, if you consider bending moment value at these two section lines, so let us consider bending moment at X. I have marked here X distance from B. So bending moment at X is equal. If you take moment about this section, that is very important. You are taking moment about this section X. That means when you take W into X, that is the value, W into X. So this is the value of bending moment, and you just see the direction. This moment is going to create a moment like this, right? So this is a clockwise moment. So according to the sign convention, here I have drawn here at the section, if the moment is like this, it is taken as negative BM, or you call it as hogging moment, right? So this is like this. This is a clockwise moment. but it is keeping the beam bent upwards. So this is convexity upwards. Lot of definitions we can say here. This is hogging moment or convexity upwards. So this is termed as a hogging moment and it is a negative moment. So I have put here minus W into X, right? If this particular load was upwards, what happens? It will bend like this. That means it will bend the beam downwards. So the case becomes here. So it is convexity downwards or it is a sagging moment. So take it as positive beam. But here in this case, we have got here upward direction of moment so that the beam is bent upwards. So your case is negative BM. So it is hogging moment I have written here, that is W minus WX. Similarly, if you take this section X1 also, I have marked here the distance as X1 section line from your free end B. So again the moment is again coming as a clockwise moment, or it is making the beam bend upwards. So it is same as the case of this particular sign convention. So it is coming upwards, so it is a hogging moment. So I have taken it as minus W into X1. The distance is X1. So W into distance to the section line is X1. So that is W into X1. So let me explain once again. For drawing shear force diagram and bending moment diagram, you need to understand the shear force values and bending moment values at each and every sections, right? So you need to understand what are the values at each and every section. So you have to get an equation for shear force at a section X and bending moment at a section X. Wherever the load is varying, you need to have different equations. But here in this simple example of a cantilever AB subjected to a single concentrated load at the free end, you have taken a section XX as well as section X1. So this is the free end B and this is the fixed end A. At the fixed end, you have got a fixing moment as well as a vertical reaction. This we have already studied in the first year. So then this cantilever, as per the definition of shear force at a section and bending moment at a section, you have to consider algebraic sum of the vertical forces either to the right or to the left of the section for shear force, as well as for bending moment diagram you have to take the algebraic sum of the bending moments either to the left or to the right of the section. So in that particular case, here you have got the option to consider either to the right or to the left. But since we are not evaluating these values, the moments and reactions at the fixed support, it is easy to consider the free end side. So always for cantilever, you consider the free end side only. Okay, so that is easier and you will not get confused. So when you consider the free end, I have taken all the distances of the section XX and X1 from the free end, and I have marked the distances as X and X1 from the free end. Now coming to shear force at X, I am considering the right hand side of the section X. Only vertical load is W. I have taken W. And what about a sign convention? And I have given here to the right of the section, if it is downwards, it is taken as positive. So I have taken here positive W. Similarly, when you take bending moment, you are taking W into X, which is a clockwise moment. As per the sign convention, this is your section line. If it is a clockwise moment, it is coming in this category, that is negative BM, right? So you can understand the difference. For you are doing umpteen number of problems in this particular case, then only you will register this concept. It is very important. Please be careful while studying this. Please go through the text also. I will just show you problems also.